Welcome to the next part. In the last part, we are discussed about the galvanic cell. Okay, so some more topics are there. So we are moving to the next one. That is electrochemical series. Electrochemical series. So, what is an electrochemical series? Electrochemical series, it is the ordered arrangement of reduction potential of various elements from most negative value to most positive value. We know that electrode potential, that is reduction potential, and it can be found in any way. We have reduction potential of all elements, and if you arranged that elements in the increasing order of reduction potential from more negative to more positive, then we obtain a series what we called as electrochemical series. Okay, so what is electrochemical series? Arrangement of various elements according to their increasing reduction potential. Okay, so increasing the reduction potential means there is an increment of more negative to more positive. The order is from more negative value to more positive value. Okay, so let me show the category. The top first one is lithium, then potassium, then barium, then calcium, then sodium, then magnesium, then I think aluminium, followed by manganese, then zinc followed by chromium, then iron. Okay, then cadmium, nickel, tin, lead. Okay, then hydrogen, copper, iodine, silver, mercury, Hag, then mercury, followed by bromine, chlorine, platinum, gold, fluorine. This is the order of electrochemical series. Okay, so no need of by hearting this all. So you want to know that this is the element with the most negative reduction potential, that is the values minus 3.05. Okay, and fluorine is the element with the most positive reduction potential, which means electrode potential plus 2.87. And hydrogen have a reduction potential of 0. The reduction potential is 0. Okay, so actually this series below this one, ready. So elements which lying below hydrogen having electrode potential or reduction potential of positive value. Hydrogen has 0 value, and the elements which lying below hydrogen is having an electrode potential of positive value, and elements which lying above hydrogen. Okay, these all are existing above hydrogen, so they have an electrode potential value of negative. So this is an arrangement from more negative to 0 then positive. Arrangement of various elements according to their reduction potential or increasing order of reduction potential, and increasing order sense is from more negative to more positive. Okay, and this is defined in 298 Kelvin. Ready? And there are some applications for your electrode potential. Okay, applications. The first application, before entering to the application, you have to know that if displacement through, if displacement is, you know what is displacement, it is already in the top, element in the top can displace element in bottom. Okay. For example, listen here. Listen here. I have a compound of copper sulfate. Copper sulfate. Let your zinc is placed in it. A zinc is in contact with the copper sulfate. So there may be a chance of displacement of your zinc to copper. And this displacement is through electron lossing, right? Yeah. For this displacement, zinc have to lose 2 electron, whereas copper have to accept that 2 electron. Check whether it is possible or not. So if the electron displacement is through a loss of electron, then element in the top can displace element in the bottom. Fine. So what are the position of your zinc and copper? Copper is in the top, whereas zinc is in the top, whereas copper is in the bottom. Okay, this is below this one. Okay, ready? So zinc exists in the top of electrochemical series, whereas copper exists in the bottom of electrochemical series. So this displacement is easily possible. So it becomes ZnSO4 plus what? Cu. ZnSO4 plus Cu. And the reverse is not possible. For example, I have MnSO4, which on treatment with the zinc. Check whether the reaction possible or not. That is the case. Okay. So here the displacement is through electron losing, no doubt. For a reaction or for this displacement, zinc have to lose 2 electron and manganese has to accept 2 electron. Check whether it is possible or not. It is not possible because zinc existing below manganese, not on the top of manganese, just bottom of manganese, right? So since zinc exists in the bottom of manganese in your electrochemical series, this displacement is not possible. So that is one of your application of your electrochemical series. And one more case is that is if displacement through electron gain, then if the displacement is through electron gain, then the reverse may happen. What? Then element in the bottom, of series can displace element in top. So element in the bottom of series can displace element in top. Is it okay? For example, listen here. If I have fluorine, which on treatment with the KCl, let it be 2 KCl. What happens? There is a chance for displacement of fluorine by fluorine, and that displacement is through electron gain, right? Yes. Here chlorine gained electron, For this displacement, fluorine have to gain electron and chlorine have to lose electron. Check whether the fluorine can gain more electron more than chlorine. Yes, it is possible because the element in the bottom of electrochemical series can gain electron very easily and displace the other. So fluorine is in the bottom of your electrochemical series. So it can gain electron and it can displace what? Chlorine. So what happened? This displacement is possible so that it become 2Kf plus what? Cl2. Okay. I'll give you one more example. That is, if I have iodine for the displacement of chlorine from KCl. What is the condition? Chlorine is in the bottom, iodine is in the top. So iodine not exists in the bottom of series. If it exists in the bottom of series, then only it can gain electron than the other. So iodine for there is no displacement in this case. Okay, so we can easily predict whether a element can displace another or not. That is a main application of your electrochemical series. And there are some more applications. We are moving to that. Okay. So the next application that is, listen, the next application that is, listen carefully. Next application, element with a greater reduction potential. Greater reduction potential means more positive reduction potential. Greater means more positive. Always act as cathode. Act as cathode. Similarly, element with a lesser reduction potential, lower electron reduction potential. Lower reduction potential means more negative. Act as anode. Which act as anode. Ready. The next application, element with a greater reduction potential. Greater reduction potential. Greater reduction potential means more positive reduction potential will be a we know that element with a greater reduction potential which exists in the bottom of series which can accept electron, right? If it can accept electron means it easily undergoes reduction, which means it's a good oxidizing agent. Will be a good oxidizing agent. Okay. Similarly, element with a lower reduction potential. Lower reduction potential means more positive reduction potential which exists in the top of the series which can easily lose electrons, so which can easily undergo oxidation, which means that is a good reducing agent. That is the next. Okay. For example, I have A, B, C. Have A, B, C. A having electrode potential of minus 3.01, B having electrode potential of plus 2.3, C having electrode potential of 0.05. Arrange them in the increasing order of reducing tendency. Reducing order, reducing tendency. Which one can act as a greater reducing agent? One with a more negative reduction potential can act as a greater reducing agent. So A will be a greater reducing agent. Then as the negative value decreases, reducing character decreases. So this will be a good oxidizing agent. So the next is for your C, then is for your B. Okay. So you may ask to arrange there like that. Okay. The next application, that is, listen, next application can predict the EMF or standard EMF of cell, okay, without constructing. So no need of constructing a galvanic cell. Before that, we can easily predict its standard EMF. And we know that it is using the equation E0 cell is equal to E cathode minus E anode. E stands for reduction potential or electrode potential. For example, I have a combination of zinc and copper, a combination of zinc and silver, and a combination of copper and silver, which means I have three different types of galvanic cell. And let me predict its cell potential or EMF. For that, I need the values from electrochemical series. I need the reduction potential values which is from your electrochemical series. For zinc, that is minus 0.76 volt. Copper, that is plus 0.34 volt. Silver, that is plus 0.80 volt. Okay. Once you know this value, you can easily predict the cell EMF without constructing that cell. Okay. So equation E cell is equal to E cathode minus E anode. Which one is a cathode? We already discussed that one with the greater reduction potential will be cathode. So zinc and copper. Zinc, copper, greater reduction potential is for copper. So copper is the cathode. So potential of cathode minus the potential of anode. So this one will be 1.10. Okay, zinc and silver. So which one will be cathode? One with the greater reduction potential. So it is silver. So the cell EMF will be plus 0.80 minus. Minus is from the equation, and the reduction potential of zinc minus 0.76. And this answer will be plus 1.56 volt. Copper and silver, which one will be cathode? Cathode. Copper, silver. Greater reduction potential is for silver. So silver will be cathode. So equation will be plus 0.80 minus plus 0.34. So this is, I think, 0.46 volt. So without constructing this cell, we can easily predict its cell EMF. That is the next application. Let me discuss the last application. Can predict whether metal can displace hydrogen from acid. We can easily predict whether the metal can displace hydrogen from acid. So there are 2 points. That is, if metal lying below hydrogen, which means their electrode potential will be positive, right? Yes. So they are not able to displace hydrogen. Can't displace. Okay, for example, copper plus sulfuric acid, there is no displacement reaction since copper which lying below hydrogen. Similarly, a counterpoint is also the metal lying above hydrogen. How can we find that a metal which is lying above hydrogen or not? Yeah, if it lying above hydrogen, its electrode potential will be negative. It can displace. It can displace hydrogen. For example, zinc with a negative electrode potential which can displace hydrogen. So zinc plus sulfuric acid, zinc easily displaces the position of hydrogen and becomes ZnSO4, so that hydrogen will be liberated. So these all are the main applications of your electrochemical series. Okay, so we are moving to that calculation of electrode potential. How we can calculate this electrode potential? Once you calculated this electrode potential, then only you can arrange this in the increasing order, and then only you can formulate the electrochemical series. Then how the calculation of electrochemical series proceeding? Okay, so what are the difficulties and how it become possible? That is the next topic we have to discuss. Okay, so listen, measurement of standard electrode potential. Measurement of standard electrode potential. Okay, it is not possible to find independently. Okay, it is not possible to find the electrode potential independently, which means if I have an electrode like a solution of Zn2 plus where zinc electrode is dipped. Okay, so we can't find the electrode potential between this electrode and electrolyte independently. For that, we have to complete a circuit, and the electron flow should be there. Then only we can find the potential difference. Okay, so it is not possible to find independently. Hence, to connect to complete a cell, they introduced a reference electrode called standard hydrogen electrode. Okay, so a reference electrode used. A reference electrode used, and that reference electrode is known as She. The expansion is standard electrode potential. Standard electrode potential. That is the expansion of your She. Standard electrode potential. So what is She? How it can be useful for finding electrode potential? She is a gas electrode. She is a gas electrode. Ready? And let me draw its figure. She have, if standard means there will be a 1 molar concentration of ionic part. Ionic part of your hydrogen is H plus, no doubt. Like 1 molar concentration of Zn2 plus and a zinc electrode in it. Like that, 1 molar concentration of an acid, 1 molar H plus. Where a platinum electrode is dipped. Platinum electrode is dipped. Okay, to increase the reaction rate, the end is connected with the platinum foil. The end is connected with the platinum foil, which means platinized platinum. Platinum is coated on another platinum. Platinum black is coated on metal. Platinum foil, simply said to be platinum foil. And this is a terminal for the connection. And over this, there is a glass tube. Glass tube. Okay. There is a glass tube, where this glass tube consists of hydrogen gas at 1 atm or 1 bar pressure. This glass tube consists of hydrogen gas at 1 atm or 1 bar pressure. Okay, so this setup is simply said to be a gas electrode. A solid electrode means simply a solid which is dipped in its solution. A gas electrode means an inert electrode like platinum, which is surrounded by its gaseous atmosphere of that particular electrode. Here the electrode is hydrogen. So a platinum is surrounded by its hydrogen atmosphere. where it is dipped in its own solution. The solution of hydrogen is 1 mole, H plus. So this is simply the setup of your She. Okay. So what are the properties of She? Simply its electrode potential is arbitrarily taken as 0 volt. The electrode potential of She is simply assumed as 0 volt. With reference to She, the electrode potential of others are defined. With respect to She, the electrode potential of copper is plus 0.34. With respect to She, electrode potential of zinc is minus 0.76. Okay, so this is a relative sense. Ready? Our first property is electrode potential is simply taken as 0 volt, and it can act as anode. Can act as anode. She can act as anode. If she is act as anode, then its representation will be like this: Pt H2 bar H plus. This will be the representation of She. Pt H2 bar H plus. Okay. If zinc act as anode, how we can represent it? Zn bar Zn2 plus. Right? Yeah. 0 state become 2 plus state. Here 0 state become H plus 1 state. And what is the use of this Pt? That Pt indicates that it is a gas electrode, which means inert platinum is the which is surrounded by hydrogen. That is a meaning. Okay. So no need of mentioning Pt something like that in your solid electrode. It is only used in your gaseous electrode. Okay. So it can act as anode. It can act as anode, or it can act as cathode also. If it acts as cathode, the representation will be like this: H plus bar H2Pt. Okay, if it acts as anode, what will be the reaction? H2 become 2H plus plus 2 electron, and if it is in a cathode, then the reaction will be its reverse: 2H plus plus 2 electron gives H2. Okay, so how we can measure the electrode potential of another substance using She? That's also we want to discuss. Listen here. Okay, if I connected a zinc with the She, how it will be? Here we have Zn2 plus solution where zinc electrode dipped, and we have the solution She. Okay, She, that's She, like that. It is connected externally with a voltmeter and internally with a Saalbridge. Anyway, this is zinc and this is She. So here as cathode, we know that zinc and She, the greater reduction potential is for, or greater potential is for zinc. Sorry, She. More positive potential is for She, which means She acts as cathode and zinc acts as anode. Okay. So here is a voltmeter reading, right? By connecting this cell and working this cell, here we obtain a cell EMF. Ready? Let the cell EMF be x volt. And we know that cell EMF is E cathode minus E anode. So if that x volt, the cell EMF is x volt, it is equal to E cathode. What is E cathode? It is E cathode means it is your E cathode means it is your She, right? E anode means it is the potential of your zinc. And we know that this will be 0 because electrode potential of She will be 0 and minus of Zn2 plus bar Zn will be x volt. So it is clear that electrode potential of Zn2 plus is bar Zn is minus x volt. Okay, so this how. Okay, for that we can use what? She. Okay, if She acts as cathode, then the reading will be the negative of electrode potential of the reading will be x volt will be the negative of electrode potential of anode, electrode potential of substance which is taken as anode. Similarly, if you simply think that, okay, if your She act as anode, then what happens? This part will be 0. So that electrode EMF reading will be the exactly equal to the potential of cathode. So we can easily find electrode potential of any substance, you see, or in a connection with the She. And we already determined that all electrode potential, and we already arranged it, and what it is said be, and it is known as electrochemical series. Okay. So with the help of a reference electrode, we can easily find the electrode potential of other elements also. Okay, fine. That's all.